Thank you. Good morning. My name is Mikko Kontio. I'm from Secora Systems, and it's good to be here. I was looking through the list of participants online, and I was happy to see a lot of familiar names. So, good morning to everybody that I know, and of course, good morning to everyone that I haven't met. So let's network later, and please feel free to ask any questions if there are anything. I might answer the questions at the end, so because it's quite a short time. Just a few words about Secora. Secora is a software and consulting company, and we do a lot of trainings as well. We've over the past few years we've seen to focus on data analytics and IoT. So any environment or any use case, any business case that has a lot of data requires a lot of wrangling of the data and presentation of the data. That seems to be where we've done most of the work. Like I said, we do a lot of trainings on data analytics and data, and then we also have software products. And these lessons learned in IoT, I think the headline said in the agenda was like lessons learned in IoT projects, but maybe it's a more general lessons learned in IoT. So let's see how I get here. All right, yeah. So I'm going to talk about four key findings or four, let's say, lessons that we've learned. Number one is that instead of selling the technology, you should aim at selling or solving the customer's problem, because the customer might be very interested in talking about technology, but what's the challenge? What's the problem? So that's the first one. Then a second one is talking about connections or connectivity. It has a lot of let's say that a lot of aspects of the customer solution has an effect to what kind of connection, what kind of connectivity should you use. So that's another topic. Then another one, the third one is talking about in IoT, typically we sensor, we monitor things, but that's just the first half of the problem. So you should really focus on, if you're buying an IoT solution, then focus on thinking through the whole process. So like what happens after you monitor and after you find some data. And then the last one is about accessing the data from the customer's point of view. So those are the four learnings that I've put together. And okay, so first let's focus on what the challenge is that the customer is trying to solve. If we would go to a customer and say that, okay, we want to talk about IoT, then it will be probably a very nice discussion. We will talk about the possibilities of IoT. We will talk about how IoT is transforming businesses. But more important than just talking about the technology is trying to find out what is the challenge that the customer is solving. Quite often the customer is trying to monitor something. They have assets. When I say asset, it means something valuable to the customer. It might be a building, it might be a vehicle, it might be a cold storage unit, it might be a factory machine. Any asset that is valuable to the customer, they probably want to monitor the state of the asset, and they might have a distance to the asset, or all of the assets might be in one location, one site, and it's just a question of seeing all of those assets and the states, like the condition of the assets at one. Another problem that the customer might be solving is to know when something goes wrong. So instead of someone looking at those monitors, like on the photo of or on the diagram on the left, if something goes wrong, you have a list of predefined conditions, and if something goes wrong, you get an alarm, and then you know that you have to do something. So you know if one of your assets is at risk. Another problem that they might be having is that they have their assets spread widely, let's say inside a country or inside a continent, and they want to know what's happening in those assets without anyone being physically there. And if something needs to be done to those assets, they will know what is happening there and what sort of problem does the asset have. And then the final challenge would be a very obvious one. Probably the customer needs to report the monitoring or the condition of the asset to someone, either to their own processes, or they might, if it's let's say if it's a cold storage unit like a freezer or a bigger unit, they might have to report that to an authority that the temperatures of those units have been remained in suitable ranges. So instead of talking about technology, aim to solve the problem. And if you're the buyer, um, um, think about think about all the problems that you need to solve, and then walk into the process of meeting providers and technology partners. All right, then the aspects of connectivity. Yeah, I'm on time. First one, of course, what networks are available. In Finland, we have, let's say, quite um, different situations depending on which city or which area you are. If you're in one of the major cities, you can pick from many networks, many connection networks. And if you're in rural areas or somewhere up north, then it might be that you only have one or two choices for the network. So first of the aspects is what networks do you have available throughout the solution. So if you have the solution in one location, let's say a factory or a building, office building or something, it's easy because you know that the location is not going to change. If you have the solutions in many sites like different cities, then you have to check that which of the networks are available everywhere, so that you would be able to provide a service or let's say an installation with minimum different kinds of networks. And then if those units are moving, like vehicles or processing units or anything that moves, then of course you have to take that into account. Then power. We've been working quite a lot in construction, and power is a very important thing. You especially notice the importance when the power is not reliable in every part of the day. So um, you have to know if you have network power, if you have grid available, or if you have a vehicle that has like a larger battery and maybe a motor that would charge the battery. Or if you don't have any of those, then you're down to devices or solutions that are cell powered, or like small batteries, the kind of batteries that you put in your remote control. And of course, if you come down with the available power, that like you're dealing with cell batteries, then it has an effect on the devices and the network that you're going to use. If you add location services like GPS, which uses a lot of power, then you are you're restricted to use some of the possibilities like GPS and let's say couple AA batteries, and even if you recharge them, it won't last very long. You will have to make sacrifices on how often you update the data to the cloud. And then the last part is data intervals, like how often do you send the data and how much data do you send when you send the data. If you have to send data every 30 minutes, you have a quite nice range of options that you can do. If you have to send a lot of data every minute or even more frequently, like several times a minute, then you can't really use a battery operated device, or the batteries will run out in just like a couple of weeks. And then you have to come up with a, let's say, a schedule or a maintenance schedule to update those batteries, and that's always like an extra work. So there are several aspects that affect what kind of network you can use. We've been using Sigfox, we've been using LoRa, we've been using, of course, GMS, 2G, 3G. We haven't done any 5G implementations. Uh, from the use cases that we are typically solving, it seems like 5G would go into applications or use cases where you're using a lot of data and the latency needs to be really small. So, for example, remote controlling a tractor on a field, plowing a field, or something like that. And we've mostly been in monitoring and censoring at the moment. So these real-time heavy data applications, maybe they will come later. Also, the connectivity, when Pekka was mentioning about cloud and edge and mist computing, I recognized some elements like, of course, cloud is quite, let's say, everyday well, it's everyday for most of the customers. They don't really want to install their own servers. They don't want the hassle of running their own environment. So they just want the service. Depending on whether there's a lot of data or a little data, they just want the convenience of logging in and everything just works. Everything is like the data is collected automatically. And edge computing and mist computing was actually like a new term, the mist, but I think we've done that as well. So we've done some solutions where we compress the data on the sensor end of the network or the solution, and then we just send the compressed data to the cloud service, and it seems to work quite well, because then you don't have to send data that often. You can rely on like even if your network connection is not stable or it's not that fast, then it seems to work quite well, and even the use case is still properly taken care of. All right. Then I promised to talk about just the censoring is just the first half of the problem. So let's paint a picture here. So first, you monitor. You have some assets. You might have some vehicles. You might have some buildings. You might have some any assets, and you monitor them. And then something happens. You get an alarm that one of these values is above, like a freezer is warming up, or a vehicle is outside certain geofence, or the battery of the vehicle is running down, and there needs to be work done. Now what happens? So you have to be able to manage, you have to be able to trigger the maintenance work that comes after it. Typically, this comes down to two choices, like two ways to handle it. One is that the IoT solution itself is also a work management solution, so that you can trigger, we call them work orders, but you can just call them tasks or whatever you do. That's the one case. And the other case is that the IoT system should be able to trigger the work order in an external system. So if the customer has already a work management system, and this IoT monitoring system is just an add-on to that, then the IoT system should be able to trigger that. Because if you leave the work management or the maintenance work outside of the solution, then you're actually just creating more problems, because the customer can see that there's something wrong with the assets, and to take care of that, it requires quite a lot of hassle. But you can actually automate the whole thing. So where you're monitoring all your assets, and you have set some we call them event definitions, which is pretty much like a template for an alert. Like if a value goes like the freezer, if it goes too warm, then we set an event or an alarm, and then something happens. So we have the freezer, we have the alarm, and then we can trigger either a work order inside the system, or we can trigger it to an external system. So if you're buying an IoT solution, think through the whole chain of events, like what you're doing, you're monitoring, then something happens. either periodically or as an accident, like as a surprise, and then you have to take care of it. You have to manage it. So think through the whole chain of events. All right. The last thing, the fourth thing that I promised to talk about, the access of data. And this really changes a lot, even inside one company. Different people, different roles of people, they have different needs, or they have different likings, how they like to access the data. Some people like to build dashboards. They just like to look at the certain KPIs or trend lines of the data. They like to see how vibrations are going in a machine, or they like to see how the temperature or humidity or particles in the air, how they are changing. And that's the only thing they want to look. They don't want to have a look at any of the reports. They just want to have the dashboard. They might have it open on the wall like a screen that everybody can see, or just overall go there once or twice a day and look how things are going. Then in other cases, our system, the IoT system, might actually not be the center of the operations. So the customer might have another system which is the center of the operations. So a really good, easy to use, efficient, fast API is crucial. That needs to be solved. So the IoT system needs to be able to either push the data out or have an API where the external systems can ask for data, and ask for information about the assets or anything like that. So in that case, if you provide an API, or if the IoT solution provides an API, then the customer can tie it into their architecture, instead of the IoT system being like well, if you could say, a silo in the worst case. In some cases, maps are really nice if the assets are spread widely, if in different cities, different areas, then a map might be like a really nice starting point to view the data. You have your list of assets, you have a map, you see the assets on the map, and then you click one of the assets, and then you can see what's happening with that particular asset. And in some cases, when you have like one factory or one building, the map doesn't really make sense. In that case, maybe a list is something that is more workable. You have a list of all the assets, you have a list of all the devices, and it's a lot faster to access the data and to browse through all the possible assets. And in some cases, we have this in construction. There's particular workflow where they like to get their reports as PDF in email, which works best for their workflow. So when they need to transport that or actually store those reports in an external documentation system, it's really easy. They get the report in an email, they open it, and they see that everything is fine, and then they just store it in the documentation system. So in terms of accessing the data, like which way is better, the more the merrier, it seems really. So even, like I said, even inside one company, it can change a lot. Different people, different roles, they have different kind of requirements, or even just like habits of looking at the data. Some people like to, like I said, just look at the dashboards and look at the very crucial data, the most important data, and they like to build their own dashboards just to see. They might have like 20, 30, 40 assets, and they want to see health metrics on the assets. They might want to see the KPIs of some of the assets. They might want to know the problems or the alerts, the events, and whatever that is. And some other people like to go into details, so maybe lists are better for that. All right. So as a conclusion, this is pretty much the same slide as the first slide, like my agenda of the presentation, but with the key takeaways. So if you want to take something away with you from this presentation, maybe this is like a good summary of that. So think about the real problem the customer is solving. Says don't sell. If you're the seller, don't sell them. Check if you're the customer. Think about what is the complete challenge that you're solving, and focus on that. And then IoT is just one technology. Connectivity. uh, we came to a conclusion. I know that there are a lot of companies that focus on one connectivity. There might be LoRaWAN companies, or there might be Sigfox companies, or some might even aim to be like a 5G company. We've learned that we have, yeah, the more network options that we can offer, the better the solution that we can build for the customer. So even if we have like a multi-site solution in different cities, we can deploy, we can install different kinds of devices in different locations, depending on what network works best for that site. Then we were talking about censoring, like censoring just the first half of the problem. Think about what happens when you get the alarm. What sort of a process do you have for the maintenance work, or whatever you call it? Is it like um, just well, maintenance work, or um, any well, typical work. And then the last point, the fourth point, was accessing the data, which seems to vary quite different, quite hugely, even inside companies. Like some people like quick overall views, and some people like to dive into the data, and that should be possible. So thank you.